In this video, you will learn how to find the solution for knapsack problem using memory functions. In the previous video, I have discussed how to find the solution for knapsack problem using bottom-up approach. So here, the algorithm name is V and I and J are the parameters passed here. I indicates the items and J indicates W, that is capacity of the sack. Initial value for I and J is N and W, and global variables W, small v and capital V is used. Small W and V are weights and values of N items, and V stores the result of the problem. So initially all the entries is initialized with value -1 in the table capital V. 0th row and 0th column initialized with values zeros. If Vij is less than 0 and if J is less than Wi, that means capacity of the sack is less than the weight of the ith item, in that case value will be Vi minus 1 comma J. That is, whatever value you have earned by considering I minus 1 items with capacity J, the same value is retained for the ith item. Otherwise, that means if you can able to accommodate the ith item into the sack, look at whichever is maximizing the value that you have to consider, whether by accommodating the ith item into the sack or without accommodating. So whichever is maximizing the value, that value you have to consider. So without accommodating the ith item means V of I minus 1 comma J. If you accommodate the ith item into the sack, then you have to find out the value Vi plus Vi minus 1 comma J minus Wi. So maximum of these two values is assigned to value. So finally Vij will be equal to value. Return the Vij value. So for the same instance, we'll apply this memory function algorithm and find out the solution using the algorithm. So initially all the entries is equal to -1 except 0th row and 0th column. Next, you are required to find out VNW because our objective is to find what is V4, 5. So V4, 5, if you want to find out, then you need to know what is V35 and V33. In order to find out V35, you need to know what is V25 and V22. Similarly, V33, in order to find out that, you need to know what is V23 and what is V20. Similarly, in order to find out these three values, you are required to know all these values. Then only you can able to find the value of V45. So initially the algorithm will be called for V45. So the same thing is traced here. V45 is equal to maximum of V35. So value of the fourth item is 15. 15 plus V3 comma J minus Wi, that is 5 minus weight of the fourth item is 2, that is 3. Next, in order to find out V45, so V35 you are required to calculate and V33 you are required to calculate. V35 is equal to maximum of V25 comma 20 plus V22. So V25 is calculated like this: V15 10 plus V14. Then V15 is maximum of V05 12 plus V03. V14 equal to maximum of V04 12 plus V02, and these two values V15 V14 is 12. So substitute that value, you can get the value for V25, it's equal to 22. Now you are required to find out V2, 2. V2, 2 is equal to maximum of V12 10 plus V1, 1. It's equal to 12, 10. the maximum is 12 and V12 is 12 and V11 is 0. So substitute this value here. V35 can be found like this. So maximum of V25, already we found the value, it is equal to 22 and 20 plus V2 comma 2 is 12. So maximum of these two value is 32. Now you are required to find out what is V3 comma 3. V3 comma 3 is nothing but V2 comma 3 20 plus V20, because weight of the third item is 3. So 2 comma J minus 3, that is 3 minus 3 is 0. Then in order to find out V33, you need to know what is V23. V23 can be found like this. Max V13 10 plus V12. Then V13 can be found like this. So once you got the value for V13 and V12, substitute that values, that is V23 is 22, V33 is 22. Substitute that value here. So V35 is 32. 15 plus value of V3 comma 3 is 22. So maximum of these two value is 37. So we have found the value of, with this we have found the value of VNW, that is V4 comma 5. In order to find out which items is being included, in order to optimize the value, we need to backtrack in this table, so that you will come to know which items is being included into the sack in order to get this value 37. So 4 comma 5, that is V4 comma 5, is it same as that of V35? No, it is not same. So item 4 is included into the sack. When item 4 is included into the sack with weight 2, then the left capacity is 3. Now check V3 comma 3, is it equal to V2 comma 3? It's same, therefore item 3 is not included. Then check for V23, that is second item, whether it is included or not. For that V23, here it's not equal to V13. V13 is 12, it is not the same. So item 2 is included. Item 2 weight is 1. So left out capacity is 2 here. Again check for item 1. Item 1 with weight 2. Whether you can accommodate or not, that you are required to check here. V12 is 12. It's not equal to V02. So item 1 is included into the sack. So left out capacity now it's equal to 0. So when you backtrack here, these two are not same. Item 4 is included. When item 4 is included, now the left out capacity is 3 only. So consider 3, whether it can be included or not. It cannot be, because item here V3 comma 3 is same as that of V23, so not included. Now check for V23. V23 is not same as that of V13, so V2 is included here. That is item 2 is included, and when you have included item 2, the left out capacity is 2. Check for V12. V12 is not same as that of V02, so item 1 is not, item 1 is included. So therefore the optimal solution is item 1, item 2, item 4. When it is included into the sack, you can get the optimal value, that is equal to 37. You can write in the vector format also, 1 1 0 1. This is the optimal solution you are going to get whenever you include item 1, 2 and 4 into the sack. One interesting thing you can find out here. So here we have computed only 11 values instead of all 20 values. In earlier case, that is in bottom-up approach, in order to find out this 37, you need to compute all 20 values, but here it's enough if you compute 11 values, that is half the values what you have computed in the earlier case. So with that, you can optimize the time required to find the solution. In that way, memory function is most efficient compared to bottom-up approach to find the solution for knapsack problem. Here, the time complexity is again in theta of nw. That is, number of computation is still less than n into w, and memory required is n into w only. But in order to find the composition, that is which items is being included into the sack, you are required to do n computations. So obviously the optimal solution, that is the time needed to find the composition of an optimal solution, is theta of n only.